Here's a brief introduction of some of the functions of a digital multimeter or DMM or whatever they want to call them nowadays. Most people just call them their meter because we don't use analog anymore. I haven't seen analog in a long time. But this low Z function, that's for measuring that's for eliminating ghost voltages. You use that for more troubleshooting in an AC circuit because it'll put an impedance. It uses an impedance. It'll get rid of stray voltages in a circuit. You'll find loose connections. It's not as handy as I thought it would be, but it does help sometimes. That's your voltage AC, and you can tell it's AC by that alternating sine wave right there. That's your alternating current millivolts. That's more for like an electronics troubleshooting. You're checking for small voltages, hence the millivolts. This is voltage DC. You see the straight line and the three dots? This is like your batteries, your stuff like that. Anything that's been rectified into a DC voltage. This is your DC millivolts, which you'll find that in a lot of your electronics boards. This is also where you put your thermocouple for temperature measurements. Most people don't know a thermocouple uses a bimetallic metal that reads between 1 and 5 volts, and then it does the math in the chip of your multimeter. That's your audible continuity, that little sign thing. That's your resistance symbol. So this will give you audible continuity or resistance. That's nanosiemens. I've never used that, and tell you the truth, I'd have to look up what you'd even use that for. It's been so long since I've even had to worry about it. This one is capacitance, and that one's for checking diodes. This would be for checking capacitors. The capacitance in a capacitor, like 10 farads, 10 nanofarads, whatever. That would be for checking your diode. A diode is kind of like an electrical check valve. You can think about it. It only lets current pass in one direction. It won't let it come back. They use that in a lot of filtering circuits and stuff like that, so you don't backfeed any kind of voltage or stray current where you don't want it. This is your amps and milliamps. Now this one's important. You have to know the limitations of the meter that you're using, because you will blow this meter up in your hand if you overload the amp rating of your meter. I've seen it done. It'll fry a meter like you wouldn't believe. You also have to change your ports. It has to go through a fused port. You do not want to find out the hard way. Like this port has a 10 amp max. You run that through more than 10 amps, you will blow the fuse that's in there, and you can possibly blow this thing up. A lot of the amp clamps they use, it's almost like a step-down transformer, so it'll convert the milliamps into a regular amp reading. They just use windings. That's how they do that. This is microamps. This will be for like electronics and stuff like that, which you will need like a specialized clamp. And this one right here is your low resistance. It puts a load on it for when you're reading. This one will help you read like motors and stuff like that. If you have a winding to ground, it'll help you read that. That's what that one's for.